Okay, let's go to page 792. Start with number 1. Okay, so you got matrix A equal to 2, 1, negative 1, 2. Okay, and this one you're looking for the inverse. Okay, oh, by the way, when det equal to 0, then there will be no inverse. Okay? Okay, so again, remember the formula? The inverse equal to 1 over dt of A times by the switching of the diagonal and times by negative. Okay? Okay, so inverse will equal to 1 over dt. So again, you have to get your diagonal. Okay, so this would be 4 minus, this would be negative 1. Okay, times it by, you have to switch the number, change the sign. Okay, and now you work it out. So inverse will equal to 1 over 5 times 2, negative 1, 1, 2, and then you multiply out. So it would be 2 over 5, 1 over 5, negative 1 over 5, 2 over 5. Okay, and that would be the inverse. Okay, let's go to number 3. Okay, so you got 4, 6, 2, 3. Okay, so the inverse will equal to 1 over det. Okay, so it would be 12 minus 12 times it by 3, 4, negative 6, negative 2. Okay, and now you run into a problem. Okay, because now you have 12 minus 12 equal to 0. Okay, but you cannot have something divided by 0, right? Okay, you cannot divide by 0. So when det equal to 0, in this case you cannot. So in this case, there will be no inverse. Okay, so again, when you have det equal to 0, this one cannot, right? This is undefined, so there will be no inverse. Okay. Okay, number 5. You get 1, 1, 0, 0. Okay, so the inverse equal to 1 over det. So it would be 1 minus 0. And then you have to switch the number and you take the opposite. 0 times negative 1 is still 0, right? And so you can see that in this case, this is equal to 1 over 1 times 1, 0, 0, 1. So inverse equal to the same. Okay, notice the same. Okay, and the reason for that is because if you, like, let's say if you have A equal to 1, and the inverse will equal to like 1 over 1, and it's still equal to 1. See that? That's the reason for that. Okay, because this is the identity matrix, just like 1. So when you flip it over, it's still equal to 1. Okay. So the identity matrix is its own inverse. Okay. Okay, number 7. Okay, so inverse equal to 1 over det. So that's the 6 minus. You have to watch out your signs. Okay? So always minus, and again, I like to put parentheses just to be safe. Okay, so you have to switch the number, switch the sign. Okay? Okay, so now you can work it out. Okay, then after you can distribute. Okay, so this one equal 2 times 1 over 12 will give you 2 over 12 will be 1 over 6. This times that will give me 1 over 12. This times that will give you negative 1 over 2. This times that will be 1 over 4. Okay, and that's it for number 7. Okay, number 9. You have 2x minus y equal to 6. You got 3x plus 2y equal to negative 19. Okay, so first you have to change that into matrix form. So this you're going to get 2, negative 1, 3, 2, and it will be xy. And this would be 6, negative 19. Okay, so next step is I'm going to multiply by the inverse in the front. Okay, so I'm going to multiply by the inverse of this in the front. So that way, when you have something and inverse multiplied together, they will cancel out. Okay, so now I'm going to do this over here. So again, it's 1 over det. So this will be a 4 minus, this will give me negative 3 times it by, okay, now the inverse of this, you have to switch the 2 and then change the sign. Okay, and after that, this will be 1 over 7, and then this one over here, I'm going to multiply. So I have to use the first row times first column. Okay, so this will give me 12 plus negative 19. So this will give me negative 7. Okay, and after that, done with the first row, I'm going to do the second row. Okay, so multiply would be negative 18 plus negative 38. So this will give me negative 56. Okay, then I'm going to distribute. So when I multiply, I get negative 1. When I multiply, I get negative 8. And so that's it. So x equal to negative 1, y equal to negative 8. Okay. Okay, I'm going to try to make my bracket better. There we go. Okay, let's go to the next one, number 11. Okay, I have 2x plus 2y equal to 16, and I have x minus 3y equal to negative 4. Now, if you're wondering why are we using the inverse to solve, because in Algebra 1, you learn how to solve this before, right? So you don't really get any advantage, but the point is that they want you to use the inverse to practice your, they want you to use the easy, the easy equation to practice your using the inverse, okay? So this is just the point of this is to practice using the inverse. Okay, so let's go ahead and get our matrix ready. Okay, so this will be 2, 2, 1, negative 3, right? 2, 2, 1, negative 3. And this would be 16, negative 4. Okay, again, to solve for xy, we have to get rid of this. To get rid of this, we need to multiply by the inverse in front. Okay, now if we put the inverse in the front, we have to put inverse in the front. Okay, you have to do exactly the same on both sides. Okay, so now this will cancel out, and that's the reason for doing the inverse, so that it will cancel out. Okay, now inverse. Okay, so now we have to do the inverse of this, so it will be 1 over det. So it will be negative 6. Again, use parentheses. It helps you to keep track of things. Minus, okay, 2. And then you have to switch the number. switch the sign. That's how you do the inverse. Okay, so inverse of this is 1 over det, and you have to switch the number, switch the sign. Okay. Okay, so we're going to use the first row, first column. Okay, so when you multiply, this would be negative 48 plus 8. So this will give me negative 40. Then after I'm done with the first row, I'm going to do the second row. Okay. Okay, so when I multiply again, first number times first number plus the second number times second number, and so this will give me negative 24. Okay. Now I can distribute. So this times that, the negative cancel out, so it give me a 5. The negative cancel out, so this over that will give me a 3. Okay, so 5, 3. So that's the answer. Okay. Okay, let's go to next one. Okay, I got x plus y equal to 6. I got 2x is equal to 4. And notice I kind of skip a space over here. So you want to line everything up. So in this case, you're going to get 1, 1, 2, 0. Right? When there's nothing, 0. Times by xy equal to 6, 4. Okay? Okay. Again, first, let's go and get rid of this. So we need to multiply by the inverse in the front. Okay. So again, the matrix and its inverse will cancel out. That's the reason we're doing this. So we do the inverse so to cancel that out. Okay, so now do the det. So do the diagonal. So 1 times 0 is 0 minus this diagonal, so it'd be 2. And then we have to switch the number, switch the sign. Okay. Okay. Then after that, we need to multiply these things out. Okay. So again, to multiply, use the first row, first column. So when I multiply, I get 0 plus negative 4. So this will give me negative 4. And then after I'm done with the first row, I'm going to do the second row. Okay, so again, when I multiply, this will give me negative 12 plus 4, and this will give me negative 8. Okay, then after that, you multiply out. So this times that, by negative 4 times negative 1/2, that this will cancel out, so equal to 2. Multiply, negative cancel out, so 8 over 2 will give you 4. So the answer would be 2, 4. Okay. Okay, and that's it. Okay. Okay, let's go to the next one. Okay, you got x plus y equal to 1. You got 2x plus 2y equal to 5. So you got 1, 1, 2, 2. xy equal to 1, 5. Okay, so again, to get rid of this, we need to multiply by its inverse. Okay, so that matrix and its inverse, they will cancel out. That's the whole reason doing this. Okay, so now we have to do the DET. Okay, so that will give me a 2 minus 2. Okay, and we have to switch the number, switch the sign. Okay. Okay, 2 minus 2 give you 0. So now we have a problem, okay? Because you cannot have 1 over 0, right? So when you have this case, then you don't really have a unique solution. So answer would be no unique solution. So because you cannot do it, okay? Just cannot be done. So that's it because of this. Right? You have 1 over 0. If you try on a calculator, it will give you error. Okay?